Today we're doing right triangle trigonometry. This is actually day 3 and 4, and it's basically application problems of everything that we've been learning. And the first thing that we're going to go over is how to find the measure of the side of a right triangle. And what I always tell my students is to write SOHCAHTOA on the top of their papers, so we'll know which sides or which trig functions help us to find which side lengths in our triangle. So for example, let's say they gave us this triangle A, B, C. And if you notice, we are in degrees, so make sure your calculator is in degree mode. So you always want to look at what's given. Okay, so if you notice, we have an angle, so we don't have to just say theta anymore. We have an actual angle. And if you notice, according to this angle, we have the opposite side and the adjacent side. So you look at your 3 trig functions and figure out which trig function uses the ratio opposite adjacent. That would be tangent. So you would write tangent 61 degrees equals the opposite side, which is A, over the adjacent side, which is 10 centimeters. And it's going to ask us to round our answers to the whole number. So what you do is you solve for A. So you multiply both sides by 10. So in your calculator, you're going to actually do tangent of 61 degrees. Make sure you close those parentheses and multiply that by 10. And that'll give you the side length for A. So I'll do that really quickly. And rounding that to the whole number, that would give us 18 centimeters. And of course, each problem won't involve tangents, so you have to really look and see the side lengths that are given. This particular problem, I'm going to write SOHCAHTOA again. If you notice, we're given the angle 23 degrees. And according to this angle, we have the opposite and we have the hypotenuse. So you look at your ratios and see which one gives us opposite and hypotenuse ratio, and that would be sine. So you do sine 23 degrees equals opposite, which is 16 meters, over our hypotenuse. Now in this case, you want to multiply both sides by C, and you'll get C times sine 23 equals 16. And then we divide to get C by itself. That means C would equal 41 meters. So it depends on how your triangle is labeled so that you'll know which trig function that we have to use. Okay, now we're going to use a calculator to help us find the value of an acute angle to the nearest degree. And when you're doing these problems, they're going to give you something like, for example, cosine theta equals 0.8771. That means that they've already found this angle, and when they did the cosine of this angle, that's what they got when they actually did it with the calculator. And they'll tell you, for example, this if they ask you to round to the nearest degree, make sure your calculator is in degree mode. So anytime you have to find the angle, you're going to use this symbol, which is what we call cosine inverse. So that means that you're going to have to type in second sine, or excuse me, second cosine to actually get the angle. So in your calculator, you're going to do second cosine to get that symbol. And some calculators will say second, the others will say shift, whatever key will help you get to the inverse. So that would be 29 degrees. And you can always check, because if you type in cosine of 29, you should get roughly 0.87, maybe a little off. And then if they ask you to do it in radians, then of course you want to make sure your calculator is in radian mode. And we're going to round to 3 decimals. So you're in radians, and now you do the sine inverse key of the value that's given, so you can find out what radian measure gave us a sine of 0.9499. So that would be 1.253. Okay, so make sure you read the directions so you'll know which mode and which unit they want your answer. The last section is just extra practice on everything that we've been doing so far. So I'll just do a couple practice problems to make sure you guys understand. So if I had 1 over cotangent pi over 4 minus 2 over cosecant pi over 6. One thing that we want to do is make sure that you understand our basic radians. Pi over 4 we know is 45 degrees. So if you're doing cotangent of that, and what will help is if you have your triangle, your 45-45 triangle, which is always 1, 1, square root of 2. If you had to do cotangent, which would be opposite over, or the reciprocal of opposite over adjacent, you know that it'll still be 1. So that value would be 1. And then over here, I'm going to leave the 2. Now I have to do cosecant of pi over 6. And we know that pi over 6 is 30 degrees. So I'm going to label this triangle. Cosecant is the reciprocal of sine. So we're doing hypotenuse over opposite, which is 2. So we have 1 minus 1, which gives us 0. So that's just extra practice on those. And then you may have an example where we're using one of our identities. There are different ways you can do this, but I see that that's 80 and 10, and I know that that adds up to 90. So automatically I think about a cofunction. So I know that the cofunction of tangent squared would be cotangent squared. And I know that they have to add up to 90, so this had to be 80 degrees. And then I know that if I rewrite this, then now I have a Pythagorean identity that this whole thing equals 1. Therefore, I have the 1 that was already there plus the 1 I got from Pythagorean identity, and now my answer is 2. So, some of these problems, what we're doing is trying to simplify it so that we get values that we can easily cancel. Here's another practice problem. These problems really make you think. Here's another problem where I noticed that these angles, they both add up to 90 degrees. So somehow I'm going to have to use my cofunctions. And I know that the cofunction for cosine is sine. I know it has to add up to 90, so I'm going to change that to 78 so that these two are exactly the same. Then I'm going to do that over here. Since I chose 78, I'm going to make all the angles 78 degrees. And here, I'm going to have to change that to cosine. And now, I can make a Pythagorean identity, because this is now sine squared, because I'm doing sine times sine. And this is cosine squared. And I know that sine squared plus cosine squared of any angle is always equal to 1. And here's another one. If f of theta is equal to 2 times sine of theta minus sine of theta divided by 2, find f of pi over 3. Well, I know that pi over 3 is equal to 60 degrees. So basically, I'm plugging in 60 degrees for theta. And right here, this is 60 divided by 2, so that's 30. So, what I need to do first is find sine of 60. So here's my 30, 60, 90 triangle. So across from 30 is always 1, that's 2, that's the square root of 3. So 2 times sine of 60 will be opposite over hypotenuse. And then sine of 30 would be opposite over hypotenuse. Which means I'm going to have 2 root 3 over 2 minus 1 over 2. And since my denominators are the same, and I can't really subtract it, but I can put it together so it can look like this over one single fraction. So that's what they mean by write it as a single fraction. And then the last practice problem says if theta is an acute angle and cosine theta equals 1/3, find cosecant of pi over 2 minus theta. So I know that cosecant, this whole thing, every time I see something about 90 or pi over 2, I know that that refers to a cofunction. And I know the cofunction for cosecant is secant. So this whole thing is equal to secant of theta. So now I don't even have to worry about this anymore because I know that that's secant of theta. So if they're giving me that cosine of theta is 1 over 3, and I know that cosine and secant are reciprocals, then I can find secant of theta because I do the reciprocal, which is 3 over 1, or 3. So those are practice problems that will help you think, help you strengthen your brain, see if you really understand the 6 trig functions and their relationship. That will conclude our lesson.